Hi everyone, I hope you're having a good HBL day. I'm going to I'm going to continue with yesterday's lesson, or rather on Wednesday's lesson on reference angles. This is 10E of the worksheet I gave in class. Okay, so if you remember yesterday, we spoke about, or rather on Wednesday, we spoke about reference angles and what reference angles are. So just a quick recap. Reference angles are when in the X and Y coordinate system, in the X and Y axis, okay, there are 4 quadrants. The first quadrant, the second quadrant, the third quadrant, as well as the fourth quadrant. Okay, and then we spoke about how at the different quadrants, at the 4 quadrants, for every angle, we can find its corresponding acute angle, and that will be called the reference angle or basic angle. Okay, so for example, if my angle is at the first quadrant, then the angle will be equals to our reference angle. Okay, so the basic angle will be equals to our reference angle. Maybe I will just bring you all to the next page to show you all that, right, in case you missed this out from yesterday's lesson. Okay, so if your angle is in the first quadrant, then your angle is actually equals to your basic angle, right? So alpha is equals to your theta. Whereas now, if you are in the second quadrant, right, then your angle theta is actually in the obtuse angles, bigger than 90 but less than 180. Then the corresponding reference angle will be between the angle or the line and the x-axis. So in this case, our alpha, it's 180 minus theta, or if it's in radian, pi minus theta, right? And if we move on to the third quadrant, then your angle is actually greater than 180 but lesser than 270. And the corresponding acute angle, by definition, will be the angle from the line to the x-axis. So this angle here. So that will be theta minus 180 or theta minus pi if it's in radian mode. Right. If your angle is in the fourth quadrant, okay, that means you are all the way greater than 270, greater than 270 but lesser than 360. Then your angle alpha will be between the line to the x-axis again, and this time will be 360 minus theta or 2 pi minus theta. Okay, so we already covered these 4 quadrants yesterday, and I also used the examples of the graphs, okay, to show all of y'all that that at the 4 quadrants, the sine of the sine function, cosine function, and the tangent function changes. Okay, so the sine of them, okay, not sine as in S-I-N, okay, so sine of sine, cosine, and tangent will change depending on the quadrant. So in the first quadrant, okay, all the 3 values are positive. They're all greater than 0. Okay, so all positive. In the second quadrant, okay, how will the sign change? In the second quadrant, okay, I'm not going to explain again. So in the second quadrant, the sign of sine function is positive, but the rest are negative. Okay, so only sine is positive. All right, and then in the third quadrant, we have tangent being positive and the rest are negative. So only tangent is positive. Okay, and finally, in the last quadrant, we will have that only cosine is positive, the rest are negative, right? So that's why the acronym ASTC came about, and that is in our third page over here, ASTC. Okay, so now I'm going to go through the examples. For example 1, to demonstrate to all of y'all how you can use ASTC, okay, to actually solve or to find values of cosine, tangent, and sine without the use of a calculator, and how all the angles in each of the 4 quadrants are actually related to the acute angle. Okay, they're all related to their corresponding acute angle or their basic angle per se. Okay, and I believe you should have watched the SLS video by now. If you have not watched the SLS video, I encourage you to watch it because it's very similar to what I'm going to go through. Okay, so if you can, you try the question yourself, then you can check your answers later on. All right. Okay, so for example 1 says without the use of a calculator. Okay, so that means working must be shown. Okay, so you show working. Show relevant working. You're asked to evaluate the following, okay, leaving your answers in certs wherever possible. Right, so first step is you want to identify what is the angle, right? Is this angle, which quadrant is this angle in? Okay, so step 1, identify which quadrant angle is in, okay, and then you step 2, find corresponding basic angle, okay, and then step 3, solve, right, or use your special angles over here. Okay, so now let's start. Cosine 120, if you draw it out in your x and y axis, sorry, into my ink, it's not working. Okay, it's a bit laggy, let's try again. What's going on? Okay, not sure why they would draw multiple lines for me, but it's a bit laggy now. Let me try to refresh the app. Okay, there we go. So 120 degrees means the line is over here at the second quadrant, right? So this angle here, 120 degrees. Okay, and so what is the corresponding acute angle? The corresponding acute angle will be here, the basic angle, right? So, and you know that in the second quadrant, or you know that in the 4 quadrants, A, S, T, C. In the second quadrant, cosine is actually negative, which means that cosine 120 is equals to the negative of cosine 60. Right, and where do I get the 60 from? Our alpha here is actually 180 minus 120, the basic angle. Okay, so this negative sign comes from being in the second quadrant. In the second quadrant, only sine is positive. Cosine, tangent are both negative. In this question, we are concerned about cosine. So cosine will be negative. The cosine of 120 is negative of the cosine of 60, right? And this shouldn't be surprising to you because we have already learned this formula, remember? Cosine theta equals to negative cosine 180 minus theta. So this ASTC, right, is an extension of this formula that you all learned in E-Math, right? Okay, now we know that cosine 60 is a special angle and cosine 60 is actually half. So you just have to sub in half. Done, right? And if you don't believe me, you can always take out your calculator and punch in what is cosine 120. right? See, the calculator will tell you that cosine 120 is negative half, right? And if you type in cosine 60, okay, it will be positive, right? So that's why we have to have the negative sign in front because we are in the second quadrant. So ASTC is an extension of what you all learned for obtuse angles. So now you can extend beyond obtuse angles. We can go to all the different angles already. All the angles can all have a corresponding basic angle. Okay, so that's pretty cool, right? Okay, so now we're gonna go on to the second question. Let's do tangent 225 first, okay? So first step, you identify which quadrant 225 is in. If you draw it out, 225 will be here. This is 90, 180, 225, right? Oops. Okay, so somewhere here, this is 225 degrees. Okay, and where is the corresponding basic angle for this angle 225? It's the angle between the line and the x-axis. So it's over here. Okay, and this is our alpha. So alpha will be 225 minus 180 degrees, right? Which is 45 degrees. Okay, and the four quadrants, let's look at the sign now. The sign A, S, T, C, right? In the third quadrant, where our angle is, tangent is positive. Therefore, tangent 225 is positive tangent 45. Okay, so positive, I don't need to write the sign. No sign, assume it's positive. Right, and therefore, the answer, tangent 45, is a special angle 1. Okay, so likewise, you can use your calculator to verify. Tangent 225 is 1. See that? And tangent 45 is also 1. Okay, so for every angle, like I said, for every angle, there will always be a corresponding acute angle, right? And the value is the same. It's just that what sign it is. What sign it is depends on which quadrant you belong in. Alright, so if you're confident by now, you can go ahead and try part B and part D, but I will go through because part B and part D is on radian mode. Okay, so notice the units for the angles have changed now. Alright, okay, so let's look at part B, sine 3 pi over 4. Okay, so again, first step, identify which quadrant this angle is in. So let me draw it out. Okay, so if you're still not familiar, you can write this down. This is 0, okay, and then 90 degrees is pi over 2, 180 degrees is pi, and then 270 is 3 pi over 2. So when you are at 3/4 pi, 3/4 means you are lesser than 1 whole, right? 3/4 you are lesser than 1 whole, but 3/4 is also more than half. So therefore, your angle is here. So this angle is 3 pi over 4 radian. Okay, and then where's the corresponding acute angle? Here. It's our corresponding acute angle. And our corresponding acute angle is pi minus 3 pi over 4, which is pi over 4. Right? So now, we just have to identify which quadrant this is in. A, S, T, C. So this value here is going to be greater than 0. It's going to be positive, and it's equals to the corresponding basic angle, pi over 4. And sine pi over 4, it's a special angle, right? It is actually square root 2 over 2. Done. Okay, let's check. Let's check our answers. How do I go to the other one?